Hey guys, welcome back to my channel GLITCHEDVELO. I'm your host Wazahat, and in this video we are going to learn how to create shaders in CopperCube 3D. So the shader language which we are going to use is HLSL, which stands for High Level Shading Language, and it works only with direct 3D renderers. In your CopperCube 3D editor publishing settings for Windows EXE platform, if you have selected OpenGL as your 3D video driver, then it will not work with your CopperCube game or application. In order to make it work with your CopperCube game or application, we need to confirm that Direct 3D is selected as our 3D video driver in CopperCube publishing settings for Windows EXE platform. In this particular video, we are not going deep into the programming part of HLSL language because this video is more focused on CopperCube 3D. So in this video, we are going to learn what features and functions CopperCube provide us to write a shader. For example, shader callback, shader constant, and what format CopperCube uses to write a shader. So I am going to use this example shader which comes with CopperCube documentation for the demonstration purpose of this video. I have already copied this example code from the documentation into my Notepad++ and has removed all the string iterations from this code so that you can understand it better or to make it work with my syntax highlighting. And I have also selected language HLSL language as syntax highlighting language for my Notepad++. You might not see HLSL in your Notepad++ language because you have to define it as user defined language. You can find the link in the description down below for the language pack. So before starting, I want you to know that HLSL contains three main components. One, Vertex Program. Second, Fragment Program, and third, techniques and passes. And in CopperCube, while writing shaders in CopperCube, we don't have to use the third one. We don't have to write techniques and passes. All we have to do is write our Vertex Program and our Fragment Program. So the very first thing we have here in our shader code is variable Vertex shader, which is actually a JavaScript variable. And what it does is it tells CopperCube that the value this variable is holding is our Vertex program. And then we have same variable with another name or with different name as a fragment shader, but it's a JavaScript variable fragment shader, and this variable tells CopperCube that all the code here is our fragment program, or the value this variable has is our fragment program. You can name it whatever you want. You can name it Tom, Harry, something like that. You can change the name to whatever you want, variable name to whatever you want. And then we have our matrix, three matrix, and these are constant which CopperCube provides us. So the first one we have is mWorldViewProj, which is our world view projection matrix. Then we have minWorld, which is our inverted world matrix. Then we have mTransWorld, which is our transposed world matrix. So these three are the constants which CopperCube provides us. Then moving on to our shader. So this is our vertex shader, or you can say vertex program, from here till here. So all of this is our vertex program or vertex shader code. And then we have our vertex shader output structure. And what is the struct, or what this structure is? So it tells, basically it is like ingredients. It holds all the ingredients we are going to use in our shader, or all the ingredients, or you can say all the properties which we are going to output to our pixel shader or to our pixel program here. So for example, we want to output our position, or diffuse is our color, diffuse color, and texture coordinates. So we defined it here in our structure that we are going to use these three values or three ingredients. For example, when you want to cook or make coffee, you already know that you are going to need milk, you are going to need coffee, you are going to need sugar to make coffee or tea. So this is something like that. So creating shader is like knowing recipe of the shader. So these three are our ingredients which we are going to pass to our fragment shader. For example, our position, color, and texture coordinates. So structs hold all the ingredients which we are going to pass or output to our fragment shader. Then we have vs output main, which is our function, and main is the function, or main is the name of the function which CopperCube uses automatically to assign techniques and passes. That's why we don't have to write techniques and passes, because CopperCube automatically assigns techniques and passes to this main function for the vertex shader as well and for pixel shader as well. So we don't have to write techniques and passes. And in this function, what we are doing is we are taking the input from our CopperCube application to our Vertex program. For example, we have v position, which is the position of our object to the Vertex program. We are taking the position from CopperCube 3D editor or CopperCube application and then transferring it to our Vertex program. Same goes for normal and texture coordinates. So these three are the inputs from the application to the Vertex program. People also call it A to V, which stands for application to Vertex program. Then we have the vs output, which is actually the part of this function here, and we do all the calculations in this section here in this part of function. So we know that we are going to output the position, so we output the position to our fragment program. Then we calculate this normal in this shader, in this particular shader. This is not used, so you can delete it if you want. Then we are going to output the diffuse, which is our color. Then we are going to output the texture coordinates. Then we return the output. A function always ends with the return, so we return the output to the fragment shader. So all of these output position, output diffuse, and output text codes are already mentioned or already described or defined in our structure here. If you see float for position, then we are outputting the position, output dot position. Then float for diffuse, then we output the diffuse color, output dot diffuse. Then we have float to texture codes, text code, then output dot text code. So we are outputting all these ingredients to our shader, fragment shader, from this function, from this output function. Then we have our pixel shader or fragment program, variable fragment shader. And then we also need to define our structure for pixel shader output, because we know that we want to render the color on our screen. So we have defined float for RGB color as a color in our structure, PS output structure, or you can say pixel shader output structure. And then we have float for pulse and sampler 2D text. So float for pulse is a shader constant which we have defined here by using a shader callback in our material here and a myShader callback function. So we have variable time here, variable pulse here, and then we define the shader constant by using the JavaScript API CCB set shader constant in our shader callback function, and then we use it in our pixel shader. We are going to know that about in a few minutes, how we can use shader callback or shader constants. Then we have our sampler 2D text 0. So this sampler 2D is used for getting the texture. So text 0 is our text, 0 is this texture, and then we can have text 1, text 2, text 3. So CopperCube allows us to use 4 texture slots. So texture 1 is our text 0, texture 2 is our text 1, texture 3 is our text 2, and texture 4 is our text 3. So you can use whatever texture slot you want here. Then we have our PS output main. So again, this is the main function, and CopperCube uses it to assign techniques and passes. So you can't change the name main here. You can't change it to something like Lane or Dane or Bane or Tom, Harry or something else. But you can change this struct name. You can change the struct name to whatever you want. So main also has these input values, but these are not from the application. These are from the vertex shader or vertex program. So we have output our position, output our diffuse color, and output our texture coordinates in our vertex program, and then we input them in our pixel shader. So float 2 text code is our text code 0, float 4 position is our position, float 4 diffuse is our color 0. So we have defined these in our vertex shader output here, that we are going to output the position, output the diffuse color, and output the texture coordinate in these 3 slots. These are the slots. So float 4 position will go in position slot, then diffuse will go in color 0 slot, then text code will go in text code 0 slot, and then we output it by doing the calculation in our vertex shader output function. Output.position will be input position from the application program and then multiplying it by the matrix world view projection. Then we have output diffuse as white color, then output text code is our text code which comes from application. Then in our pixel shader we are inputting all these outputs. So float 2 text code is our text code 0 slot, text code 0 slot, then position is our positions is in our position slot, then diffuse is in our color 0 slot, as we can see here in our structure of vertex shader output. So we are inputting the values, or you can say the floats, from vertex shader to pixel shader here. So you can call it V2P or input from V2P. So vertex to pixel. And then we have PS output function which calculates whatever we want. For example, float 4 color is text 2D, which is our function, HLSL function or intrinsic function of HLSL. Then we are pointing out our texture 0, texture coordinate, and then outputting the RGB color. So output RGB color is the float 4 RGB color which we have defined in our structure pixel shader output. So whatever we put in our structure is the value we output to the CPU or to the render on the screen, or to output to the fragment program. So we need to output these values whatever we use in our structure. If we don't output these values, then it will give us an error in our shader code or shader program. So output.rgb color is pulse. Pulse is our shader constant multiplied by our color. Call is our color of the texture. So text 2D, text 0, text code will provide us color of the texture. And then we are returning the output function, and then we are returning the output to our screen to render the pixels or those. And now we have our myShader callback function. So this is CopperCube constant function. So we have this CCB set shader constant here, and you see 2 here. What is this 2? So this 2 is that this 2 tells this function that we are going to use this constant pulse in our pixel shader, or you can say our fragment shader. If I use 1 here, then it tells CopperCube that we are going to use it in our vertex shader, or you can say the first component of HLSL program. So first component of HLSL program is vertex shader, and the second one is our fragment shader, or you can say we are going to use it in our second variable, fragment shader. And the name of the constant is pulse, and these are the values this pulse hold. So we have defined float 4 pulse here, float 4 pulse, because it holds 4 values: pulse, pulse, 0 and pulse. And these values are coming from this variable pulse, which is the percentage of time or divided by 500, which is time again, I think. Then we have new material. Then we are creating material from this vertex shader, fragment shader, and our shader callback. So we are going to use CCB create material JavaScript API. Then we define our vertex shader here. So whatever name you give to your variable vertex shader, you are going to use it here. Then we are going to use our fragment shader. Whatever name of your fragment shader variable will be used here. Then we have our material type. 0 is for solid. And then we have to define our shader callback function. So that this shader constant will get provided to our pixel shader. If you don't use shader callback here, then it will throw you an error that variable float 4 pulse is not defined or something like that, or it will just don't give you the desired result. So then we are going to apply this new material to our cube mesh. So variable cube is our object. CCB gets scene node from name. We are getting the object cube mesh 1 from here, and then applying this material, newly created material or shader, to our object by CB set scene node property, material property cube. Cube is our object. 0 here is the material index. So as you can see here, we have material index of 1. So it is not 1, it is right now it is 0. So if it has 2 materials, then the second one is our material index 1. It might be, you can say, somewhat confusing, but yeah, that's it. 0 is our material index. Then we have type. We are doing what we are doing. We are changing the material type to our new material, this material. So let me just show you by applying this shader code to our application in CopperCube 3D editor. Let me just go over here and copy this code from here, and in my application I will go to behavior. Then in behavior triggered by events, when a key pressed will be F, and then special execute JavaScript. And if I paste it here, and now if I run my application and if I press F, then this cube will start blinking. So it says unrecognized identifier met for, I think I have copied something else. Yeah, we have copied this OpenGL or GLSL example. So this is a mistake. We are going to use this one here. So let me just copy it again and paste it over here. So now if I use it here and if I press F, this will start blinking. So as you can see, it is blinking now. And one more thing I'm going to show you now is that whatever we put in our structure, we need to output it. Otherwise the shader will give us an error. For example, if I copy this or duplicate this float for diffuse and rename it to glitched, 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 and now if I copy paste this over here in our application, execute JavaScript action, and now if I press F, then it will give me an error that glitch is not outputted or something like that. So it gave me an error. or it throws an error. Now how to fix that? So glitched, and I'm going to use it for color 1. Then I'm going to output this glitched by going over here, copy it, paste it, and then output dot glitched. There'll be float 4 value, and it seems correct. Everything seems correct. And now if I copy paste this, it should work fine. And if I now run the application, press F, then it starts blinking. So whatever you put in your structure, you need to output it to your fragment shader or vertex shader or to the screen, to render on the screen. So whatever you put in your pixel shader, you need to output it in your main function ps output, and whatever you put it in your vertex shader output structure, you need to output this to your fragment shader by using output dot glitched or whatever you define here. And if I change this 500 to 100 in my shader callback function, and if I paste it now, then you will see that the blinking speed will become faster. If I press F, then the blinking will become faster. Look how fast it is blinking now. So you can do whatever you want with the shaders. So in CopperCube, shader consists of 3 parts: the Vertex program, fragment shader program, and third one is shader callback. Third one is optional. You are not forced to use my shader callback or callback function. You can simply put null here, null, null, and use your shader. But then you have to do the calculation in the vertex shader or pixel shader. You can't do the calculation outside and then set shader constant for that value or that calculation. So it will just become blue because the value of pulse or the variable pulse is not passing into the pixel shader, because we haven't defined our shader callback function here for our new material. So in order to pass this value pulse to our pixel shader, we need to use our shader callback function here in new material. So I'm going to do it, or you can say undo it and copy paste it now, and it will work again. And if I run the application, it starts working. And one more thing, if I change this to 1, then it will give me an error. So 1 is used for vertex shader and 2 is used for pixel shader to set our CCB set shader constant. So if I copy paste this now, then it will throw me an error, I think. So it throw me an error: 𝑚_world_view_proj registers begins 0, count 4, and HLSL variable to set not found pulse. So we have set our constant here pulse, but it is not going in pixel vertex shader because we have set 0, 1 here. The first value or the very first value in our shader constant, which is 1. So we have to define it in our vertex shader if we want to use this pulse variable. So for example, we have variable pulse here, and if I cut it from here to and paste it in my vertex shader program, then that error will be gone. If I copy it, all right, if I copy it and paste it in my CopperCube action, and now if I test the application, So it throws me an error because I haven't used this constant anywhere in my Vertex program. I have only defined it. So in order to make it work, you need to use this variable somewhere in your code. So for example, I can use it in float output diffuse multiplied by pulse. And here I'm using pulse, but pulse is not defined in my pixel shader, or you can say fragment shader. So I can remove this, and I have done multiplication in here output.diffuse. And if now I copy this and paste it here, then it should work. So it is not showing me any effect, but it is also not giving me any error. So the shader program or the shader code is working correctly, but as we have defined our pulse in here in our Vertex program, so it is not giving me any effects. So I can do or undo the changes to make it work again. So if I set this shader constant to 2, then it will start working again. So that's how shader works in CopperCube 3D. I know it might sound confusing and shaders are a bit complicated subject, so but yeah, this is pretty much it, how you can write shaders in CopperCube 3D, or this is the format that CopperCube uses to write shaders in HLSL language. Hopefully this is all about today's videos, and hopefully in next video we will create a basic simple shader from scratch. We are not going to use, or we will be not going to use any example code. We are going to write it from beginning to the end, and that shader will do pretty much nothing, but will change the color of the object. So that's it. I hope you understand the video, and if you find this video useful, give this video a thumbs up. And if you are new here and if you haven't subscribed already, please subscribe to the channel. And for real-time interaction, you can join my Discord server. The link will be provided in the description down below. That's it. Bye bye. Good day. Good night. Have peace.